Gabriella Signorini from Polytechnic of Milan, another case study regarding medical device solution for maternal health. If you can start the slides, okay. Thank you for being here.
Okay, good afternoon. This presentation is a case study about the technical and technological design solution for monitoring, fetal monitoring, maternal monitoring, so monitoring during pregnancy. So we know that problems arising during pregnancy affect even postnatal life. So it's really important to predict as soon as possible problems that can arise from the pregnancy condition, both for the fetus and for the mother. This is a case study. In our interpretation, in our approach, we will present a first part which is dedicated to the signal processing analysis in order to identify the best parameters that can be extracted from fetal heart, from the functioning of the fetal cardiovascular system, and from the maternal heart. Then, starting from these physiological related parameters, we move to some technical and technological examples of application of monitoring, fetal monitoring in low resource settings, which is the core of this school. Then the presentation will be shared with Nicolò Pini. I know some of you know him because he closed his PhD some years ago, a few years ago at the Polytechnic di Milano, and he is now at the Columbia University working in this issue. And so he will present the second part of this talk. I don't know how to. Ok. Questo. Okay, so we concentrate today on the best practice. Can you tell me 15 minutes? Okay, in such a way to. Okay, thank you, Stefano. The best practices to design and an inclusive remote pregnancy monitoring framework. Okay. The outcome of this presentation is summarized here. So the first part would be dedicated to measure in pregnancy, physiological meaning and usefulness, because any kind of methods analyzing and predicting behavior in physiological signals is based on true parameters related to physiological behavior, physiological functioning. Then fetal heart rate measurement and their importance in the pregnancy monitoring. We will see some case studies in Malawi and South Africa and in Tanzania and Guatemala. And then we will finish with open challenges for biomedical engineers. Sorry, too fast. Okay. goal, the main goal of any kind of monitoring, in this specific case, we are looking at the fetal monitoring, pregnancy monitoring, is to assess the fetus and mother well-being. So obtaining indicators that are able to identify changes as fast as possible, changes in the condition of the mother and the fetus, in order to minimize risks of fetal morbidity and mortality, and to identify at-risk fetuses during pregnancy, and to evaluate also the optimal timing for the delivery. Also, the maternal health is an issue, because in particular in these low income settings, the role of the mother, as the mothers have more than one child and they are the center of the family, the mortality, the maternal mortality is a key factor to be analyzed, to be monitored and possibly predicted. We have to remember that 5 million perinatal deaths occur in low resources settings. So, and the 50% of them is during in intrapartum period. So both prepartum and intrapartum monitoring can be improved in order to face this very important problem. Okay, which is the most used tool to monitor fetal behavior, fetal state in high resource settings, as the ones in we live, is the cardiotocography. Cardiotocography is a system, is a device that measures together the heart rate activity of the fetus. There's a pointer here. Okay, the heart rate of the fetus, which is shown here, and the maternal contraction. Maternal contraction reveal the activity of the maternal uterus, and can be related to the can be related to the time of the delivery. So the technique used is an ultrasound Doppler technique. So an ultrasound Doppler probe is put on the maternal abdomen, and the two signals, the heart rate of the fetus, the fetal cardiac frequency of the fetus, and the contraction are recorded. Sorry. Okay, this is an example. I wish to introduce you to the point which is the measurement, that we need to perform a monitoring, useful monitoring of the pregnancy. And this is the object of our monitoring. And this is the representation of the fetal heart rate and the uterine contraction. So you see that the signal is an heart rate variability signal, so showing oscillations that are related to physiological phenomena, such as acceleration, so increase of the number of beats, and deceleration, are all related to the activity of the fetus. Presence of a certain level of variability means the fetus is healthy. So starting from this kind of signal, we can extract information related to the fetal condition. sorry. No. Okay, doesn't matter. Unfortunately, cardiotocography is a device, cardiotocography is a system, is a device, which can be used if we are in presence of an expert personnel that is able to set the device and a no-hospital-like context. Even in high resource setting, is quite impossible right now to perform a fetal monitoring outside an hospital-like context, such as at home. Some research is in progress about it, about this, to obtain this result, but we have no, right now, a solution, a commercial solution, a easy for the user solution. So consider this as an open challenge, even for your activity, for your research. So, okay, then again, this is the screen obtained by a cardiotocographic system. And what is in the upper part of the screen are the parameters, some parameters that some feature that are extracted from this signal. Which kind of feature? Many features. So the signal can be analyzed, has been analyzed, and the device has been modified accordingly through time domain parameters, quantifying variability, acceleration, deceleration, and so on. Some parameters in the frequency domain, quantifying the amount of oscillatory components that are involved in the control of fetal heart rate, and even nonlinear parameters, which is the idea in this approach, is that we need a set of features, all related to some different aspects of the physiological fetal heart rate functioning. So the research developed in such a way to provide this set composed by different views of the functioning of the fetal heart rate. Okay, these are events that occur in the fetal heart rate, acceleration, deceleration, and what is called baseline, such as the average line that identifies the behavior of the signal. Okay, the fetus can show different shapes in its fetal heart rate. So we can have lower variability intervals, then higher variability intervals, and lower again. The fetus basically moves, is active, experience some sleep, which is called quieting period, and the different behavior of the fetus are marked by these differences in variability. So analyzing the variability is useful to understand, to provide a comprehensive picture and of the behavior of the fetal itself. Okay, no. Okay, so new parameters must be considered to analyze the fetal heart rate. And these parameters demonstrated their usefulness even to separate normal from pathological fetuses, which is one of our objectives. So, which kind of pathology? Even in low-income settings, the most diffused pathology in the fetal development is the one called UGR, a reduced level of growth by the fetus. So intrauterine growth restriction. And intrauterine growth restriction, as it is underlined here, can bring to the fetal death. So it's a possible condition producing a risk for the fetal life and some consequences for the neonatal life. Okay, this table summarizes the parameters that we have considered in our analysis. These are they are divided in 3 categories, as I've introduced before. The first one, frequency domain analysis, the second, time domain, then nonlinear, in which we have approximate entropy, power rectified signal averaging, so many different indicators of nonlinear signal, nonlinear components inside the signal. These parameters, this feature altogether have contributed. There are some publications, there is some research supporting this result that separate normal versus pathological fetuses with an early identification of the changes that arrive with pathology. Starting from this picture, I wish to thank you, the preceding speaker, as she introduced the approach to machine learning in starting from parameters taken from the physiological system. And even in our case, the framework was the one which is described here. So a signal processing procedure identifying some feature, physiologically based feature. So from this physiologically based feature, we can have a machine learning explainable. So explainable means that we are able to interpret, provide an interpretation of the results the machine learning provides. So in the separation, for instance, in this example of healthy and the UGR, intrauterine growth restriction fetuses. So classifier based on machine learning approaches are used to classify these 2 conditions, but not only these 2, even maternal diabetes, connection with the maternal health, and some other disease conditions. Okay, this is again a report about machine learning framework. So, proposed solution. These slides report some solutions that have been proposed for low-income settings, taking into account the powerfulness of the signal processing, because even if the first part appears complex, complicated, difficult to apply, it is not, because in this application, we can do signal processing as complex as we want in a remote way, without having the processing inside the device. The device can be really simplified, but the level of the analysis, the level of the analysis can be maintained at the highest level. Okay, even if this is very important, even if we are in a low income setting, it's not necessary to downgrade the level of the analysis. We can simplify the technology, but we can maintain, this is very important, the level of the analysis, the level of prediction. So this is an example. I reported also the paper. This system is a wearable system. The wearable solutions are very important in this approach, as they allow to measure the activity, the maternal and fetal activity in a remote setting without go in the hospital. And this is a wearable belt, and it can be self-administered. So the device is used by the mother without supervision. And we have 8 electrical sensors and even 4 acoustic sensors, because we can obtain both the fetal heart rate and maternal heart rate. It is an interesting approach because they also demonstrated that this kind of the quality of the signal that can be obtained by this approach is similar to the cardiotocographic signal quality that I have shown in the previous slides. So quality of the signal is high, so the signal remains high, and the system is very simple. We also in our group, together with the Pavia group, developed a belt based on wearable sensors that provide even not only the fetal heart rate but also the ECG. So they are prototypes. They are prototypes that can be all useful in solving this problem. And I wish to underline that they are research, PhD research results, PhD research prototypes. So another system, there are some application in Tanzania. This system is called Moyo, and this system has been used to monitor in the fetal heart rate intrapartum. Intrapartum, in these settings, the personnel is stressed why there are some different pregnancies that are the different deliveries that take place together. So personnel is found this fetal heart rate monitoring called Moyo as to make labor monitoring easier and to reduce stress, increasing the attention for each case. So an electronic strap on fetal heart rate monitor, and so this is used in women in Tanzania in intrapartum. The okay, this is the Moyo system applied to a pregnant woman, and it is based. It's very simple. It is based on 9 crystal sensor, and it detects fetal trait, and without needing the fetal position. You know, fetus is not fixed in the uterus. It moves. At the end of the pregnancy, the movement are reduced, but it is difficult to identify where the fetal heart is. Okay, so the quality of this kind of application is good even if we don't have an ecographic view of the fetal heart. Okay. Another system, very interesting, developed by a researcher from Oxford University. The name is Lisa Strew, and this group, her group. Guatemala is one, look here, of the worst maternal mortality ratio, as one of the worst maternal mortality ratio, and the highest incidence of intrauterine growth restriction. Moreover, in Guatemala, there are some places in which it is difficult to provide a monitoring as some people live in highlands, and so it's difficult to reach them. So monitoring during pregnancy, you find here the paper, is an open problem. And this open problem has been approached starting from this data. Look at this data, maternal mortality and stillbirths and neonatal mortality, very high. So the prototype of this monitoring system has been evaluated at the start in 22 women in island Guatemala in order to reduce both these two factors. Sorry, this is, sorry, why? Okay, this is the system with the main parts characterizing it. Is a smartphone. It uses a smartphone. It's performed through a smartphone, which is diffused even in low-income settings. There is a low-cost 1D Doppler, so a simplified version of the Doppler sensor, then a pulse oximeter and speaker, because the healthcare operator can speak with the patient and receive outputs by the patient. And this system can be used even by illiterate people, because it is based, this is, sorry, I don't know, okay, by screen picture. So through the smartphone, we have the identification of the patient, look in your left, and then there is an identification on of the village in which the patient, the pregnant woman is, and then feedback on the physiological signal that have been recorded, all made in a interactive but non-verbal way, in such a way to reach even people, illiterate people. Okay. Okay, this is the schema. This is the schema of the data that are and in which way the data are organized in this technical solution applied in this monitoring system in Guatemala. Sorry. Okay. Okay. Now, some open challenges remain, and to have a view about which these open challenges are, it's a pleasure to leave the floor to Nicolò Pini. Nicolò.
All right, thanks everybody for the invitation. It's a great pleasure to attend now on the other side of the podium. Okay, let's do it. So as I was able to introduce and present, there's a lot of technological and as well technical challenges to be able to conduct some of the research that she and also the previous presenter has identified in low-middle resource setting. And I think it's also a great point that most of you have been able to express this concept of the fact that we're not nowadays talking about countries anymore, but actually settings, as most of you know, in the same country, there could be high and low, but also middle income settings. And so it's really important, even in really high advanced countries, even in Italy or in the US, we want to acknowledge the fact that there's some setting in those countries where we have to pay particular attention and also to be able to adjust our expectation, but also our expertise to be able to account for some of these challenges. And so here, Maria and I came up with 4 different key words and key questions that we want to try to have you give some food for thought to be able to also think about how these are placed in your research now. Some of these are actually important moving forward. So from a technology point of view, we want to acknowledge the fact that we want to build technology that are able to work efficiently in settings where resources are scarce. And so as the first presenter, I really appreciate her being able to raise some of these points. We have to think about how to implement the research where power line is stable, where there's low level of literacy. Great. And so we really wanted to pay attention to these technological aspects. Then from a point of monitoring, and this I think is really relevant when we're trying to design and implement some of these solutions, we wanted to think about how can we scale down, most likely, and not scale up some of the solutions that we wanted to implement. And so, for example, we might have very beautiful and highly efficient system in our in the settings that we experience every day, but how does such monitoring solution apply in settings where we do have, again, some technological challenges? Education, and I think this is something which we oversee a lot, is the fact that education really plays a crucial role, and Maria was able also to introduce this concept already, in the sense that we want to have the technological solutions, the monitoring solutions we want to approach to be able to be culturally relevant for the population we're trying to target, from a point of view of the patients, but also the providers that will be able to interface with the population that we're trying to target. And then last point, before moving into actually some of the research I've been conducting in a more case study approach, is the point of improvement diversity. And we don't have the luxury of too much time to be able to talk about this, but it's just worth to think about the latest paper you published. Did you take a look at the race and background in such paper, meaning you conduct your analysis in a way such stratified by race and
And I think this is really an important point in the sense that nowadays, with this open science movement, it's really important to also pay attention to this, as we, as the scientific community, have the opportunity to be able to also promote and really work as an equalizer for being able to promote race and diversity in a way such that is really important to promote open science and also science that is relevant for the population we are targeting. Next slide, please. All right, so, and I think you can advance one further, Maria, thank you. And so here is a three picture just to make the point of where the research are going to present in the next few slides conducted. And so here, some of the picture I took when I visited recently, both in South Africa and Malawi, where we do have some research settings, and it's just to point out the fact that these settings are truly different of what we actually experience. And so the left and middle picture is what an outside of a hospital looks like, and as you can see, it looks probably to you more a city than it looks as a hospital. And as you can imagine, people travel long distances to be able to being seen by doctors and nurses, and also they don't have the luxury to be able to back and forth. So they bring their whole family, they bring their their relatives and stuff like that, and so they're able to actually live in the hospital. And then the rightmost picture is the OB ward of one of the hospital. And as you can see, is not the most welcoming environment. And so when Maria and also the previous presenter were talking about solutions that are culturally appropriate, and also making the point that we want to find solutions that are able to approach this population in a relevant way, and they're also able to be in part of their environment as much as scary such an environment might be for some of the folks. Next slide, please. And I think you can advance one further. And this slide, I'm not gonna go through this all, but this is just a long list, and I hope it's not so much overwhelming to make the point that there's a lot going on in middle income resource settings compared to what we actually experience. And again, maybe and I really hope that most of you have experienced some of this in your research, in terms that these are some of the contextual and environmental factors that we have to keep in mind when conducting research, and also think in creative way to be able to quantify some of this and include them in your research to be able to understand whether or not some of these factors might actually have an impact on the research you are you are conducting. Sorry, someone is raising the question that no slides can be seen, but I'll move forward for the interest of time. Next slide, please. All right, so here is, let's say, one of the questions guiding some of the research that Maria and I have been conducting, and also some of the research I'm conducting right now. And I think it's really important also for PhD students to think about framing the research in a way that it is relevant. And this can be irrespective of low middle income settings, but in general, really think about a research question that you want to understand, and you want to really try to contextualize in your research. And so sometimes what also Maria and I experienced when I was doing a PhD, sometimes it's not really important. It's not really aware of awareness for most people, the importance of fetal monitoring throughout pregnancy. And so most people, and she also mentioned some of that in her presentation, is the fact that people do not really think about pregnancy as a continuum, and there's very little awareness of the fact that what happens during the fetal period really shapes subsequent life and increases risk of health, but also disease in later life. Next slide. All right, I hope you can see a little bit more clearly than what I can see here. And again, I don't want to spend too much time on this. By the way, Maria, can you tell me how much time I have left? Just all right, but anyway, I'll continue. And so this slide, I think, makes a great point on the fact that, again, pregnancy is a highly dynamic period, and there's several different factors that may contribute to fetal and maternal life. But also, what is really important is the fact that what happens during the fetal period has the potential to save subsequent outcomes in neonatal as well as in the early life period, and we will see the results of some of that. And again, this is to stress the importance of the fact that we really need, or you have really need to contextualize your question and your research question in a broader scheme of things, not just to understand and answer a specific question, but rather really keeping the boundaries of your research on a specific question that you might try to answer in a given paper, and also trying to tell everybody a story about your research. Next slide, please. And I think you have the next few times to get to the next one. Again. All right, so here is an example of one of the research paper, and you can find all the references at the bottom of the page. So here, this paper was looking at a cohort both in South Africa. Actually, the data were collected in some of the same setting. You saw a picture in a couple of slides earlier, and also in the US, where we're talking about here in the US, again, not a low middle income country, but rather in these portion of population with low middle income settings. And so here is pinpoint the fact that without going yet, which will be the topic of the next slide, about any signal processing or any data that or any parameter that Maria described to you, only by looking at some of those environmental factors and contextual factors, such as smoking and drinking during pregnancy, we found that actually those pregnant individuals, both drinking and smoking during pregnancy, has almost 3 times higher risk of late stillbirth. And this is to say, again, that what we're trying to do here is not only doing we're not only in prediction or just risk assessment at the very during intrapartum, which is a big part of the pregnancy monitoring and also the pregnancy research. But what happens during the antepartum period during pregnancy really plays a crucial role in shaping everyone's risk, both for the fetal and both for the mom. Next slide. Next one. And so, leveraging the same cohort I just described to you, but actually now looking at some of the same parameters that Maria described to you earlier, we were able to also use signal processing and collecting in non-invasive and invasive way, and leveraging some of the wearables that Maria described to you. You find more details in the paper. We found that indeed we do have some biological underlying signature that can actually explain the heightened risk of such population experiencing prenatal alcohol and smoking and smoking. And this is also to say that in general, prenatal exposure to alcohol and smoking are risk factors for adverse neonatal outcomes, such as this thing that Maria described. So IUGR that we have analyzed, so talked about earlier, also STIDs, and also some outcomes that are be picked up looking at some autonomic nervous resistance profiles using some of the same parameters that she described. Next slide. All right, so we're not going to spend too much details on this one. Again, you can find the paper, and this is just to describe to make the point that we want to use agile algorithms that are able to get us the information that we want, leveraging the data from wearable devices, but also just not to in a laziness way, just rely on what algorithms that those wearables provide to you, but also push yourself forward and also develop your own algorithm to be able to extract better signal. Here's an example of a device. This is called Monica A24, which is a portable fetal ECG monitor that allows you to collect fetal ECG, which will be used for deriving some of the results described in the next couple of slides. And here we will just make the point again that we were using wearable recording in a population of South Africa and Malawi. So really the effort was toward making the device culturally relevant and also understand the acceptance of the mom of being able to use such devices in the environment. Next slide. And so, as Maria described, IUGR is a really big factor for neonatal death and also neonatal risk factors for in general. But now here I'm describing a different one, which now is becoming really more prevalent, not only in high resource settings, but actually in low resource settings, which are with diabetes and diabetes in general. It might be of surprise for some the fact that in CDM and diabetes in general has become a real problem also for low income settings, but this comes from the fact that unfortunately the access to high quality food or organic is limited in such environment, and so really relying on high processed food is the way to go, unfortunately, and so it increases the risk. And so why are we interested in TDM is the fact is because, again, during the antenatal period, this might represent a risk factor. And so what we did here was to analyze some of the same measures, just like from different devices that Maria described to you. So what we found was that indeed GDM fetus has a higher heart rate that compared to what the alpha heart. This was especially true for male fetuses compared to female fetuses, which I think also brings another point, which we really have to think about when we're running an analysis stratifying by sex. P as the outcome by actually different by biological sex or sex at birth. And what we did in this model, again, because we wanted to understand if also other critical factors may play a role in modifying or moderating this relationship, we did add also variables such as maternal age, trauma, depression, and anxiety, food insecurity, and in this analysis, it turns out it didn't really play any important role in this. Please advance. Can you advance one, please? Oh, sorry. Can you go back? Sorry. Or maybe it's I'm seeing the delay. Oh, there you go. Perfect. And what we found in the same population, again, to also make the point as the first presenter and also Maria made, we do have to think about a more comprehensive profiles rather than just 8 single variables. What we found, again, in GDM fetus with a higher heart rate, but what we found was also lower IMSS, which I'm sure most of you know as a parameters, which talks about the ANS regulation on a more fast pace and scale. So this is to say, next slide, please, that thinking about characterizing GTM in a sex stratifying analysis, but also using not just one parameter, but more of one of those, allows us to derive agents, derive risk profiles, similar to what Maria described to you earlier, so psychology-based profiles. And what it really is important, I think, is the fact that these results that we're finding here, again, this was during the third trimester, so during the fetal period, what the same profile, it was actually found for those was actually found for those individuals who later on, I mean, not the same individual, but in the signature, so the sudden infant death literature, which I'm sure most of you know what I'm talking about. So the unexplained death of newborn birth in 6 months of life. These research found the same profile characterized especially for male infants by a higher heart rate and lower RMSSD or lower ANS regulation. And so this is to make the point that in a case study way, you want to think in that way, that the role of fetal life is really crucial in shaping subsequent outcomes. And so we should be thinking about adding more and more of these variables, which physiology, but also other contextual variables, some of our predictive model. Next slide, please. All right. So in the interest of time, I'm not going to spend too much on time on this, but just to again raise the awareness and talk about some machine learning and artificial intelligence work we've been conducting. So leveraging AR architecture. The reference is also at the bottom of the slide. If you want a little bit more detail, that we are able, only using the maternal heart rate, to be able to derive clinical grade sleep staging. And so here you do have the examples of two nights for a given mom. So night one, the top in the top graph, and in the bottom you have a different night. And so this is just, and you have the different sleep staging on the y-axis. So I think at the first glance you can make the point that the second night you have a lot of more awake sleep, again, towards the middle of the night compared to the night shown in the top, which is more productive night sleep. And this is probably not so much scientifically relevant, but just to make a really nice story. So the mom herself was able to give us a clue why the second night was actually a little bit more awake time and not super difficult. If you can advance, we can read what she reported in the sleep diary. No, it's not. Sorry, can you advance one? Or maybe I'm saying.
Nicolò, mi senti?
Yes.
Bisogna arrivare in fondo.
Okay.
Thank you.
Can you advance twice then? Again. All right. So again, thanks so much for being with us until this very point. And so I'm gonna wrap up with this slide, and then I think Maria will want to wrap up the short presentation. So here are some of the lessons learned conducting some of this research in low middle income settings. So again, I want to really raise the point that contextual and environmental variables play a crucial role in interpreting signals that we all care about and we all love. But again, we really have to go beyond just using the signal, but also include some of the contextual variables to improve precision on the associations we want to derive. We also want to, Maria and I wanted to make the point that wearables offer an opportunity to enable remote monitoring and also being able to study some of the same variables we're interested in, not just in the clinics, but also in the home environment. And lastly, I'd say that research conducted in low middle income settings do present for more opportunities and challenges, as I said in the parentheses here, for the most part, because it's really definitely a ramp up and a challenging time and a challenging experience. But I think it's really worthwhile to pursue some of this while you're thinking about your PhD, but also in general, really trying to think outside the box and move your research forward, thinking about upskill and adapt that in your setting. So that was everything for me. Really, thank you for your attention. I wish I could see some of you, some familiar faces, but I hope it will happen soon next year, maybe. Thank you very much.
Thank you, Nicolò, for your presentation, for giving us a view, so extended view of what is going on in the fetal trait monitoring analysis. Thank you.